Y'all equal 9.
Well, not they don't. When you go
I got one.
I love it.
I'm just trying to figure out two sides first.
Yeah, I got my 2 sides, 18, 17.
I got one.
I'll do it up there.
Start with 9. Start with 3, 6, 9.
You're double.
Just split the number.
9. 4 plus 3 plus 3 is 10.
Plus
3 plus 2.
We can get Alex. Yeah.
1, 2, 3, 4, 5, 6, 7. So we can get 4 plus these 3. Because you're missing 2. Yeah, tell me I'm right, Jamie. Yeah. 4 plus 3 plus 3. They're nice.
I got all sides equal 21.
It's a game.
Is that good?
I don't
know. Try.
I want to figure out what each other. Nine. I want to do 8, 9, 8, 7.
Yeah, I have 18, 28, 17.
I got 21 on each side. Start with 3, 6, 9 in corners. And then on the left side, put a 5 and a 7. On the bottom, put a 2 and a 4. And on the right side, put 1.
Good stuff.
That'll equal 21 on your side.
I'm done.
Here's them just split it even. 3, 6, and 9. That was first try.
You're going viral.
How do I not hear? All right. Kurt Vile, pretty pimpin'. If I do say so myself. Give you a couple more seconds to work on it before we get into it. Got some announcements to make.
I don't know what the small side and large side are.
Okay, that's fine. I mean, not all of this is going to be solvable within, a few minutes.
I mean, the first try I got all of it.
Oh, it's not mirrored on YouTube. Oh, we're good. It's not mirrored on YouTube. This is great. Wonderful.
YouTube's better.
YouTube is better.
And every website where you can post videos. I feel like I've spent more time on YouTube than I spent on any other thing.
And YouTube's great. You can learn so much. Again, that's how I kind of became a math teacher for YouTube. Right?
I probably spend like at least 6 hours on YouTube every day.
All right, so if I do this, that's pretty instantaneous. Okay, so we're going to use this as the thing. All right, I'm going to get rid of this now. Hopefully you've seen the problem enough to know what's going on. Can I do a full screen here or no? Okay, I guess not. So we'll just leave it like that. All right, so that's us live on YouTube right now. Did you get a noti? No noties? Check your noties. Got to ring that bell, man. All right, so the problem that we're presented with here for our warm-up is another 1 through 9 problem. So 1 through 9 only once. And what we've got is, this thing is crooked. What we've got is 4 little slots to put those numbers in. Right here. Yeah, that's right. Okay. And we're allowed to use the numbers once, 1 through 9. And the idea is we're trying to make an equilateral triangle. So all 3 sides have to be equal. Notice these 3 points right here are going to count twice. All right. So anybody have a solution for us or a strategy they want to impart?
Put 3, 6, 9.
3, 6, 9 in each corner is what you did? What'd you do?
The top one has to be even.
Top one has to be even. Why does the top one have to be even?
Because it's cut in between. Because it's not uneven.
So these guys have to be even. Is that what you're saying? Or just this one?
Just the top.
So how do you know which one's the top one? You just pick one of the three to be top? Okay, you say it has to be even. So let's try yours. You said 3, what would you say?
3, 6, and 9.
3, 6, and 9 is what he did. Okay, so that gets us one of the evens. So there's a 6. Let's do 3, 6, 9. Okay? Cut off. Oh, it is mirrored. I forgot. Okay, so yeah, that view is mirrored. So do I need to open up OBS? Can I do that? I don't think I can open up OBS. All right, so here's what we'll do. I'll show the YouTube video, which is going to be delayed. Would you rather be delayed or mirrored?
Mirror.
Delayed.
Okay. So here it is. Sorry, I'll figure out a better solution.
Both of them watching this thing.
All right. Wait, what? Oh. We gotta go live. We'll do it live! It's a shame you're in here and not in the computer lab. Because then you could like open that up on all the different screens. That'd be great. All right. Okay, so here we are. So. All right, so this is very delayed. So we got 3, 6, 9. Okay, what else should we do?
Between the 3 and the 6, I put a 5 and a 7.
So a 5 and a 7. Now, notice he said between the 3 and the 6, I need a 5 and a 7. So where do I put the 5 and the 7? Which one?
Anyone.
Doesn't matter, does it? So order here doesn't matter. Again, it's not about getting the solution. It's about learning about the problem, right? So order doesn't matter for these guys. And you said one corner has to be even. Now we're going to test that hypothesis in a little bit, okay? So you said 5 and 7 here. So what do we get? Let's do 3 and 7 together and 5 and 6 together. That's 10 and 11. That makes 21. Okay? So we need 21 on the other side. So let's see if I can guess what you got here. So 3 and 9 makes 12, right? So we must have had another 9 here. How can we make 9 with the numbers that are left over?
8 and 1.
8 and 1. Okay, and here we got 15. Well, he's getting to 21, right? So the difference is 6. So how can I make 6 with the numbers that are left over? 4 and 2. Okay, so we needed 12 here, we needed 6 here, and we needed 9 there between the two of them. You see what I'm saying? Okay. So that works. Anybody get better than 21? Or should we test the even hypothesis? Oh, yeah? Okay. Give us another one. All right, give me your corners first.
8, 9, and 7.
8, 9, and 7. So we have 1 even and 2 odds again. That's interesting. All right, and what did your what was the ones between 9 and 8? 5 and 3?
1.
5 and 1. Okay. So what do we get here? Well, we got 9 and 1 is 10. 5 and 8 is 13. So that's going to be 23. Okay, cool. By the way, if we ignored the rules of having to have all the sides match, what's the biggest possible side we could have? 9, 8, 7, 6, right? 9, 8, 7, 6. Let's add those up. Okay. You could add them up in order, or you could be clever. What?
Wait, no. So I'm doing like 15 and then 9.
We're like on TikTok right now.
Right?
Let's get a bunch of those and we're good to go. All right. So 9 and 6, if we add up, are 15, right? What's the middle? Also 15. Did you notice that whenever you have consecutive integers being added, you can add the outsides and work your way in? Check this out. Gauss did this, okay? I won't do the way he did it. Gauss is like top 5 mathematician. Like he's part of the big 3 in my opinion. Really good scientist. Scientists fight a lot of time whether he's like an astronomer or what, whose club does he belong to because he was so famous. It's like, who gets Einstein, right? He was a mathematician, but he was also, a physicist, right? Gauss is fought over in math and science all the time. I think he's more of a mathematician. Anyway, so if you do 9 plus 8 plus 7 plus 6 plus 5 plus 4, that's 1, 2, 3, 4, 5, 6 numbers. What are the outsides? 13, right? What's 8 plus 5? What's 7 plus 6? So we have 3 13s. That's 36. Oh, sorry, that's not 36. It's 39. Much faster way of adding, isn't it? consecutive integers. So Gauss, when he was like 12, was in class, and his school teacher was like bored that day and didn't want to teach, and so he's like, okay, kids, here's your math lesson. Add the digits between 1 and 100 all the way, right? Go, have fun. So he gave him that, and Gauss noticed that if you exclude 100, right, you have 99 and 1. What does that make? You have 98 and 2. 100, 100, 100, 100, 100. Count them all up. Should add up to like, there's 50 of those, I think, 50 pairs, right? Plus 100, something like that. Again, I'm going to do this math wrong. It's probably, I'm off by like a 50 or something. But it should be like 50,051, something like that. All added up. But he did in like 5 seconds, right? So the math teacher had to actually like teach that day. So go Gauss. Breaking the rules. All right. So anyway, if you add up consecutive digits, it's easy to add the outside ones. So you added up to 23. You have a 9 and a 7 here. That's 16. We need 5 here. So probably 2 and a 3 or 1 and a 4. Well, you already used the 1, so it must be 2, 3, right? 4, 3? Did I add 16 plus 7 is what I want? Yeah, my bad. All right. So 8 and 7 is 15. 15, the difference is 8. So we need 8 between here. So 6 and 2. Okay, cool. All righty. So that's 23 all around. So that's the best score we've got so far. Remember, the best score we can get is 9 plus 6 is 15 plus 15 is 30, right? But that would be in a perfect world where we didn't have to worry about the other sides, right? Or we could use the numbers more than once. So 30 is our upper limit. So any other solutions? Anybody find the smallest numbers that they can get? You did? 17 is the smallest you can get, you say. How did you get 17?
1, 2, 3.
Oh, gotcha. So if you add up 1, 2, 3, and then we need another number, right? 4. What do we get? 5 plus 5 is 10. Wait, hold on. Wait, what? 1, 2, 3 for the tops? Is that what you're saying? The corners. Okay, got it. Okay, now I know what you're saying. Keep going.
5 and 9 and 2 and 1.
Okay, so we're getting 10 plus 7 is 17, like you said. We've got 2 and 3 is 5, so we need 12 here. How did you get 12? 8 and 4? Fair enough. And then between here we have 4, which means we need 13. So we need 6 and 7? 17. Anybody get smaller than 17? So our claim is that for T, which is total, T has to be between 17 and 23. And that's how you read that. You don't read this as 17 is less than or equal to T, less than or equal to 23. That's a mouthful. No, if I said that to you, you'd have no idea what I was talking about. If I said T is a number between 17 and 23, you'd be like, oh, okay. Right, 1 less than or equal to X less than or equal to 10. What does that mean to you? Nothing. A number between 1 and 10. Does that mean something to you? Yeah. Now, when we have the equal sign underneath here, where it's less than or equal to, less than or equal to, or actually, yeah. The way we say it is inclusive, so it includes 17 and 23. You can choose this as a number, right? That's what we say. Oh, yeah, and the other thing is that T has to exist in a certain set, right? Do we allow any number for T between 17 and 23? Like 17.5, is that okay? No. So our rule for T is that it has to exist in what set? What set of numbers are we working with here? There's 2 sets that would work for an answer for this. It's not the real numbers, right? Real numbers includes everything. Is it the integers? Can T be an integer? Yes or no? What's the set of the integers? Do you remember? No, we don't. Come on, guys. We're going to write about math. You need to know this crap. Think of the sets that you have. What's the smallest of all the sets? Natural numbers, right? Natural numbers are what? The ones you count your sheep with. Like 1, 2, 3. So T has to be a natural number. Now, you could have said that T could have also been what? What's something that's really close to the natural numbers? It's a whole different set for one extra number. Yeah. The whole number is very good. Thank you for opening your binder every time, and then I don't wait long enough. But you're trying, and I like that. The whole numbers will work too, because T could be 0 in theory, but it has to be between 17 and 23, right? The total amount, right? So we overshot by 1 number, but that's no big deal. Could T be an integer? Yes or no? Can T be an integer? What are the integers? Yeah, Danny.
And you never said to take 17 and 23.
No. So remember these symbols, right? Oh, dang, she thick. We have natural numbers. Oh, now you remember. Right? We got thick N. That's a whole number. Then we have the set of the integers, which is Z. Then we have the set of rational numbers, which is Q, and I can never draw it. And then we have the set of real numbers. And we also have the set of rational and irrational numbers, right? Rational and irrational, P and Q. Integers is Z. What's the set of integers include? What numbers? Yes. Exactly. So integers are the whole numbers and they're flips. Remember that? Right? It flips over the side. The N turns sideways into an Z. That's how you remember that it's the integers or the natural numbers flipped. Okay? If you flip them, we get the negative numbers. Can T be a negative number? No. We can never have a negative total, right? Now, you could say like, oh yeah, let T be an integer, but it has to be between 17 and 23. That kind of takes care of the negatives for you, right? But probably overshoot. The best thing is T has to be a natural number, our total that we get. So we say it's between 17 and 23. My question to you is why is it 17 and 23? Why is that the max? Why do we only have 6 different numbers between there? Really 8 if you count 17 and 23 themselves, that T can be. Is there a way where you can get T to be any of those numbers between there? Could you make T 18? And again, T stands for the total, right, of a side. So when you're in the next class and you're bored and you're doodling around, don't doodle. Think about this. That's why we do these, okay? Any other thoughts, questions? Oh, we didn't test the hypothesis of that we have to have an even number in the corners. So let's make not an even number. One of the ways we can test things in geometry when we're doing a proof is we can do proof by contradiction. So if we think that 8 or some even number has to be in one of the corners, we can try to show that if we don't have an even number in the corners, it never works, right? And therefore, you must have an even number in one of the corners. So let's try that. All right. So have to have an even number. Let's try all the even numbers in one of these corners. Well, we're going to do the opposite. Let's try odd numbers. So what odd numbers do you want to put in the corners? 1, 3, and 5. Why not, right? Okay. So now what are we going to do for the middle? What do you think we should do? Should we do 2 big numbers together? Should we do a small number and a big number together? 2 small numbers together? What should we do? Okay, so here's what I'm thinking. 3 and 5 are already the biggest combination, right? That's going to make 8, whereas this makes 4, as this makes 6. So this is the biggest one. So the middle stuff should probably be small to balance it out, right? So what are the smallest numbers we have remaining? 2 and what? 4. We already used 1. So what's our total here? We got 9 plus 5, which is 14. Okay. So let's try this. So we're trying to hit 14. Our next biggest side is this one. So that's the one that's going to get the middle values, whatever's left over. We want the biggest values over here to balance it out, right? That's 4, so we need 10. How can we make 10 with the numbers left over? We've used 1, 2, 3, and 4. We got 5 done. So we need 6, 7, 8, 9. Can we make 10 with any of those? We can't, can we? So we busted already. Let's try over here. Can we get 6? So 6, 14. We need 8. Can we get 8 between those? Mm-mm. So the numbers that are left over are already bigger than the number we need, right? So that's a problem. Do you know why you need an even number in one of the corners? How did you figure that out? Is it just a guess because it divides down the middle? That was your thought? Well, how do I... So my only issue with the way you phrased that, I'm not saying you're wrong. I'm not saying you're right either. Is that dividing it down the middle? Couldn't we call that a middle and that a middle as well? Shouldn't all of these have to be even then by that logic? Right? But there is something about how these are shared, right? That makes them special. So if we share 3 and 5 here, right, and they're both odds, what happens when you add 2 odds together? You get an even every single time, right? So if we have a triangle where both of these in the mid and like down here are odds, we get an even here. If this is even, what's an even plus an odd? An odd, thank you. and an odd. Again, simpler problem. This is the structure that we get. When we fill in our the rest of our circles, what happens, right? Well, if we have one even and two odds gone, how many evens do we have to work with, 1 through 9? 4, right? So we have 3 evens left. How many odds do we have to work with, 1 through 9? 5. So we have 3 odds left, which is good because we have 6 numbers, right? that we need to fill in. So if we have an odd number of odds and an odd number of evens, we put 3 of our evens down. We can split them up one in each, right? We can split our odds up 1 in each. If we double up our odds here, then we have no odds down here. You see what I'm saying? If I do 2 odds there and 1 odd there, then I have no odds down here. So I could have evens plus odds here. And we know what happens when we have an even and an odd, right? Added together, we get an odd number. Oh, pause. I forgot something. Guys, go back to where I just had the 3 circles. If I just have 3 circles, let me scribble this out. Will this be an equilateral triangle? If I only have 3 circles and I can use the numbers 1 through 9, will this be equilateral? No. Why not? How do you know? You can never use the same number, but I could do 8 and 2 and 7 and 3, right? Something like that, right? Where I could get to the same sum. How do you know that this isn't equilateral? Think about what it says. We've got an even number here, an odd number there, and an odd number there. What happens when you add an even and an odd? Odd, right? Odd. What happens when you add an odd and an odd? So how do you know this triangle isn't equilateral? Sort of. I'm not sure if you know it, if you're just really close to it. How do I know that this isn't an equilateral triangle? What I'm trying to say here, for those of you that are confused, which is like all of you, is if I have a triangle like this and I say, okay, 1 through 9, plug them in, make sure that this side, and this side are equilateral, meaning they're the same, right? But here's my rule. This has to be an even number. This has to be an odd number. And this has to be an odd number. Why is that an impossible problem? Yes. Odd plus odd is even, right? That's probably what you, right. I couldn't tell, right? How can these sides be the same numbers if these two are odd and that one's even, right? Are we still, we're not, are we? Okay, we're good. Okay, good. Sorry, scared me. So impossible problem, right? So another way to think about this one is that if these are odd and this is even, what do I need to add to an even to make it an odd, to match these other two? Need to add an odd number, right? So that means this part in here has to be odd, doesn't it? And what does that mean about these two numbers? One has to be odd and one has to be even, doesn't it? See what I'm saying? This is even right now with just the 2. So to make it odd to match the other sides, I need an odd number and an even number here. You dig? Okay, because odd and even adds to an odd. And we have odd and even adds up to an odd. So we have odd, odd, odd now. Now here's the thing. This is odd and we want to keep it odd. So how do I keep it odd? I need to add an even to it, don't I? Well, to make an even number, I can either add 2 odd numbers or 2 even numbers. Sorry, yes. So this is either both even or it's both odd. You see what I'm saying? This is both even or this is both odd. Now check it out. How many odds and evens do we have? We have 3 evens and 3 odds. Well, that requires 5 odds. And this requires 5 evens? So did I lead you astray? Did I say something that didn't make sense? Or did I not? We did one that has even, odd, odd, right? It worked. So what did I tell you that was wrong? I do this sometimes. when everybody's just like, oh, okay, yeah, sure, okay, all right, whatever, yeah, we trust you, right? You can't trust me. You can trust no one. First rule in here. You know what the second rule is? Have a plan to kill everyone you know. Odd plus even is odd. Odd plus even is odd. Odd plus odd is odd. I'm sorry, odd plus odd is even. That's what we wrote. So in order to make these all match, I need them all to be odd. So what do? I add an odd number to an odd number. And what do I get? Odd number plus an odd number is an even number. That's not what we want. We want an odd number. So odd number plus odd number gets us even. Odd number plus even number gets us odd. So what's even plus odd? Odd. So this side is odd. We did it. Over here, we already have it odd in the yellow. Add an odd number to an even number in your head. What does it come out as? Odd or even? Odd, right? So we need the number in here to be even. Because we already have odd on the outside. We need even in the middle. How do we make an even number? Add two evens, add two odds, right? Do the same here. What's the issue? Let's check this guy out. I'm going to highlight the odds in yellow. So we've got double odd, single odd, no odds over here. Right? In blue are evens, everything else. Now check it out. This is the solution. But the way I'm counting, we should only have 3 evens and 3 odds left over. Look at this, right? If we've used 2 of our evens or 2 of our odds here, we should only have 3 odds left over to use, right? If we use 1 of our evens over here, we should have 3 evens left over to use. So after we set these guys in stone, we're only allowed 3 evens and 3 odds. But yet, the way I wrote this, I need an odd and an even here. That's 1 odd, right? I need 2 odds here. That's 3 odds. 2 more odds here. That's 5 odds. That contradicts what I just said. So someone's wrong. Is it this? No, it's not. It's the way I counted. Ladies and gentlemen, pay attention. I'm going to count them again. I should have 3 odds left over to fill the middles, right? Well, here it says I need 1 odd. Here it needs 2 odds. Here it needs 2 more. I should have 3 evens left over, right? Here's 1 even. There's 2 even. There's 2 evens. So that's 5 evens. Why did I screw it up? Yeah. Did I screw it up? Am I good? Huh? Come on, guys. You're doing so good yesterday. Guys, check it out. I have options. I can either double odd or double even here. So if I have odd here and even here, and I do double odd here, what do I have to do over there? Double even. I have to because I only have 3 odds to use, right? So check it out. I just proved that if we have even, odd, odd, which you say we have to do, who knows if we do or not, okay? I'm not going to go into that. But if that's true, what do we know about these sides here? Double odd, double even in a mix. Is that what we find? Double odd, double even in a mix. Guaranteed every time. You have to. Interesting, huh? Now, again, I don't know if one of those has to be even. Is there a way you can prove that we need at least 1 even in one of these corners? Maybe there is. I challenge you to do that. 2 self-development points. Speaking of which, 2 announcements to make. Number 1. Do you think board games are boring? We can change that. 3 exclamation points. I did not make this, you can tell. Okay. What?
It's the white shirt. A clue.
Yeah, it is. I have that game. He's right back there, looking at you. Good games. Dungeons and Dragons. Satan's game. Clue, The Office, which is not a good game, but it's The Office, and you guys like The Office, right? You're either an Office person or a Friends person. If you're a Friends person, you're a moron. All right, 7 Wonders, okay? It's not even the best show from the 90s. Seinfeld was the best show from the 90s. 7 Wonders, excellent game. It's like Civilization on the computer, but like with a board game, and you can like punch people because you're within proximity. All right, boring. I guess a bunch of nerds at a table, shoots and ladders, boring. I would have put, if I'd made this, Candyland, because it's literally you draw the card, it tells you what square to sit on, and then you wait your turn, and then you do it again. It is literally the game with 0 skill, all luck. And it's not even you roll the dice, right? Dice rolling is like entertaining. What am I going to get? Drawing the card is like boring, right? Oh no, got to go to the Arm Drop Forest again. I'm so bad at this game. When am I going to get good, right? Get good, son. Double yellow, right? All right. Hungry Harry Hippos is actually a good game. We just don't have it. So I did not make this poster. But anyway, G1 is this room, G Unit. Monday and Tuesdays, 3 to 5 p.m. We met yesterday and Tuesday. You want to be here next Monday? Because if you are, then you can tell me what pizza you want for Tuesday. Okay? Attendance is not required. It's not like a club where I like punish you if you're not here. Show up and have fun. We play lots of card games, including games like Hanabi. It's Game Club. Game Club. That's right. You don't have to get Werewolf because you can play Werewolf without buying anything. But yeah, Werewolf is a fun game. It's great. One night. Werewolf is worth buying because it condenses it all down to one night, so you don't have to sit there and wait while everybody else plays when you get knocked out, right? All right, which is the only downside of knockout games. You have to sit and wait. A lot of those games are really good. You want to play Battleship but not have it suck, right? Play Captain Sonar. It's real time. There are no turns. You're in a team of 4 against another team of 4, trying to find the other person's sub and sink them. In real time, you're hearing them over the side. We're heading west. We're heading west. Okay, we think we're here. And you're freaking out because you're like, I am there. They know where we are. We gotta go, right? And they're shooting you, and you're like, we gotta move west. And like, Captain, we can't do that. The system's a malfunction. I'm giving it all I got, right? And you're like, we need to rise. So you rise in the sub, and now you're a sitting duck, and you're thinking, repair the systems, you fools, right? You're passing it around, right? That is how Battleship should be. And it is if you play Captain Sonar. Battleship's like, B7? Oh, darn. Try again next time, right? That's not a game, okay? That's like a homework assignment. Captain Sonar is a fun time, okay? You want to feel nervous like you're going to die, but at the same time, like, but we're going to get you first, right? I can't say that on TV. All right, so moving on. All right, bank shot. So let's get out the homework from yesterday that we didn't officially grade, and let's officially grade it. And then we're going to talk about this, which is what I gave you yesterday, okay? Which is going to be more for today. Did I not give it to you yesterday? I gave everybody else. Perfect. Excellent. Awesome. Fantastic. Get out the homework from last time. Let's talk about it. Okay, it's only the back side that we need to take care of. Did I chuck away my copy of that? I probably did. We're just doing morons today. It's a moron day. Not that you guys are morons, but because we're doing morons the last thing. So today is our first moron day.
Yes.
I agreed with
We love moron days. All right, I need to borrow a copy of someone's homework. Who's feeling brave?
Not this guy.
Who's feeling
I already
brave?
know I got one.
That's okay. The answers don't matter.
Yeah, it does.
It's not written on? Ah, beautiful. Nice job, Xavier. Way to not see your homework. Somebody. There you go. You guys are such an easy audience. Seriously, like, come on. Either that or my other classes are just dumb. By dumb, I don't mean not smart. I mean they don't think my jokes are funny, which makes me mad, which is why I call them names, because I'm insecure about myself.
Wow, what class?
Right? All my other ones. No, it's fine. You guys just laugh the most. It's
Did Justice
ridiculous.
think your jokes are funny?
Justice?
Yeah.
Yeah, Justice. Yeah. Okay. What's up, boy? It's my boy, Justice. All right.
Just
So-
call him Justine.
I don't think I'll do that. All right. So for number 5, I gave you the answer yesterday, but if we need to do it, we can do it really quickly. Okay. What?
Are you scared of Justine?
No. All right. So endpoint, -1, 9. And then we have our midpoint, that -9, 10. Now, there's a couple ways you can do this. You can use midpoint formula and plug it in and solve for the x and y's. We talked about that yesterday, right? Okay. Or you can do it geometrically. Let's draw our triangle. What's the distance between the x values here? -9 minus -1. 8, right? We went 8 down. Oh, wait, across, I should say. Across. And then 9 and 10, what's the difference between those? 1. Okay? Now, this is not drawn to scale, obviously, because this would be above that one, but whatever, right? We move 1, 8. So now we go here, and we do the same thing. So we went up 1. That was a plus, right, from 9 to 10. Well, we're going to go up 1 again. So where do we end up? We end up at 11 something, right? And then from here to here, we went over 8. -1 to -9. Think what direction that is. Is that left or right? Going from -1 to -9. We went left, right? That's funny how I said that. We went left, right? Left, correct? So we go 8 to the left. Well, what's 8 more to the left of 9? -17. Is that the answer you got? Okay, mark it right, mark it wrong. That's a visual way of doing it. Yeah, switch papers. I keep forgetting about that. Sorry. Oh, yeah, you want pens to help you grade? Here they are.
I grade on.
Who needs pens? There you go. I need 1 back. I need 2 back. I got them. I need 3 back. I need 4 back. I need 5 of them back. I need 6 pens back. Anybody else? No. Get them. Okay? Oh, well, I need 6 pens back. Do we have an extra?
Oh.
Why are you throwing things in my class?
And I think that was
I need 5 pens back. Oh, okay. I need 6 pens back. All right. All of them back in here, end of class, okay? I'm not buying a bunch of pens for you guys. That's all you get. Trade and grade, go. 6. Number 6. You could plug it in and do the thing and solve, right? But you could also do it visually. Here's the endpoint. It's at -6, 4. This one's at 4, 8. So it is more to the right and up. So I'm going to put it up here. That's our midpoint. 4, 8. And then our other endpoint somewhere up here. We don't know what it is yet. So we figure out how far we moved over. From -6 to 4, how much did I move? What's the distance between -6 and 4? 10. From 4 to 8, how much did I move? 4. Very good. From here to here, I want to move the same thing. So I move 10 to the right and 4 up again. What's 10 more from 4? What's 4 more from 8? Is that the answer you got?
Yeah.
That's the visual way of doing it. Okay?
I did it such an easier way.
Oh, yeah? How'd you do it?
Just did like the,
Plug in the formula or what?
yeah, like the.
All right, so this nerd over here is like, my way's easier. I asked him how he did it, and he says, oh, I used the formula. You're right. I guess that could be easier. I think this is more intuitive, personally. I move over 10, move up 4. Move over 10, move up 4. Do it twice, I'm here. That's going to be helpful for number 8. How'd you get number 8?
I got it wrong.
Yeah, there we go. Okay. All right, so number 7. All right, so number 7, it says find the quarter-way point. Not corduroy, but quarter-way. So what we can do is find the midpoint and then find the midpoint again, right? We talked about that yesterday. Let's do it visually, though. So here's 10, 8. And here's 2, 4, so says I. Now, how much did I move between those? Well, from 2 to 10, I moved 8, right? And that's 8 going to the left because I'm going from here to here. From 8 to 4, I moved 4. Down 4, right? So check it out. I'm going to draw this bigger. I moved 8 and 4 between these points. If I want to find the quarter point, what's a quarter of 8? 2. What's a quarter of 4? 1. There's the quarter point. The coordinate is not 2, 1. The coordinate is not 2, 1. It's 2 to the right of 2, 4. So if we started at 2, 4 and we move 2 to the right, what's our new coordinate? That's going to become a 4, isn't it? 2 more to the right and 1 more up. 4, 5.
Let's go.
I like that, right? When we want to find the quarter point, luckily these guys are divisible by 4, right? So just move over 2 and move up 1. If we keep doing that, over 2 up 1, over 2 up 1, over 2 up 1, over 2 up 1, we get there, don't we?
Yeah.
So that's a quarter. Number 8. If you didn't like number 7, you're not going to like number 8. Here's how I do number 8. It tells you that here's 8, -1. And here's 5, -2, right? And they tell you that's a third. Yeah? And they say find the other endpoint. Here's how I did it. I'm going to make 3 triangles, and they're going to be identical. So if that's a third, and that's a third. You dig? Well, how big is this triangle? Well, vertically, the distance is what? What's -1 to -2? How far did we move? If we're going from -1 to -2, how far did we move? We went down 1, right? If I'm going from 8 to 5, how far over did I move? I moved left 3. Do you see what I'm saying here?
Yeah.
X's are left and right, so it's 3 is the distance I moved to the left. I moved vertically down 1. I'm going to keep doing that. And guess where that's going to lead me? To the answer. Okay? So if I move left, or if I move down 1, my new coordinate here, scratch that. My new coordinate here, is going to be down 1 from here. So that's -3. And it's going to be left 3 from here. So that's +2. You see what I'm saying? -2 minus 1 is -3. 5 minus 3 is 2. That's my coordinate here. So that's 2/3 of the way. Now let's find the endpoint. Keep going. So I'm going to go down 1 from here. That's -4, isn't it? And over 3 from here. That's -1. Boom, endpoint. Sometimes visually is better than algebraically. Again, let me walk you through it. These are the 2 points that were given us. So what did I do? I found out the distance between them vertically and horizontally. Well, vertically, they're apart by 1, right? Do you see how it's separated by 1? Horizontally, 8 and 5. How much are they separated by? 3. And we're starting bigger, so we have to subtract 3. We're going to the left. That's important. I keep doing down 1 over 3, down 1 over 3, and I get my answer. You can do it on a coordinate plane. I told you to grab some, right? Some graph paper. And you can count the squares. Down 1 over 3, down 1 over 3, down 1 over 3. It's like slope, right? Everybody remembers slope. Algebra. All right, that was for self-development. If you got it right, 1 self-development point. If not, too bad, so sad. The only ones we're grading are these. They're all 1 point apiece. These 2 right here. So it's either you got a 50% or 100% or a 0. Doesn't that suck?
Wait. So these are nothing?
Nah, we're going to go. Oh, actually, no, this one is. Sorry. We got 3 of them. So you either got a 0, a 33, a 63, or a 100%. Let me say it again. A 0, a 33, a 66, or a 100%. If you got all 3, you got 100. If you got 2 of them, you got a 66. If you got 1, you got a 33.
What about the
Front side was already graded. Sorry about that. I hate when they make quizzes out of like 3 points. It's the worst.
showed us that before, I would want to do it way better.
I kind of did, actually. Ladies and gentlemen, are we out of time? Here's the homework.
Hey, Mr. Max.
Yo.
Yo.
Not yet.
Start
Put them in the
throwing
bin. Put them in the bin. Your homework for tonight is over midpoint and section formula. I want you to give it a shot. We're going to talk about it more tomorrow. Tomorrow's our review day. This will basically be the quiz. So if you knock this out of the park, except for section formula, you'll probably do well in the quiz. If you struggle with section formula, you'll get it tomorrow, right?
Wait, Mr. Mack, I need my dog.
I got you.
Even.
Got one?
Yeah. I'm returning your pen.
This is basically a review, except it adds on section formula, which I know you can do. It's ratios.
Is this what the other classes got yesterday?
Yeah, basically, yeah. The notes are there if you need them.
I can't come in Monday.
No.
School Monday.
Oh, yeah, you're right. Yeah. Okay, I won't be here either. I'll see you when I see you, okay?
Okay.
There you go.
We don't have school on Monday.
Nah, Labor Day. Thank your unions. Watch where you're going. Yeah, you. Watch out, okay?
Watch where you're going.
So
When
sorry.
do you want me to get my homework for next week?
You're gonna be gone next week. Can I put it on Google Classroom and then you can just grab it from there? Is that okay? Or should I get it to you Friday? Do you have a paper copy?
Either one.
Okay, I'm gonna be honest, I probably don't have the homework made by Friday. And if not, I don't care if you don't care. Okay, yeah, just get to me whenever. Hello.
Miss Grimm told me to come to you to ask if I can start at chess club.
Yeah. I have my chest set right back there, let's do it. My name's Mr. Mack, what's your name?
Rylan Unger.
Rylan. How do I spell it, Rylan?
RYLEN.
L-E-N? Why do you spell your name incorrectly? Your parents know? Should I tell them?
Yeah.
Okay. All right, so chess club. We meet Mondays and Tuesdays because it's basically just game club. So I'll see you next Monday and Tuesday. Make sure you're here Monday because we're going to order pizza Tuesday and I need to know what you want, okay?
Great.
See you Monday, 3 to 5 in my room.
Do I have time to go get a Pop-Tart from my locker?
Pop-Tart? What kind?
Brown sugar cinnamon one, I
Do you have
think.
2 of them or just 1 of them?
2.
Go ahead.
Okay.
You owe me.
Okay.
It is, I'm sorry.
So I'm here.
Yeah, PHS Robotics.
This is not my shirt.
Okay,
It's my boyfriend.
gotcha. He's a robot nerd?
I guess.
Awkward.
I don't know. Probably not.
All right, live stream over. Oh yeah, we're live right now, by the way. To YouTube.
Okay, well, I need homework from yesterday and the day before. Can I play with one of your,
No, don't say it.
the black?
Like and subscribe, that's right. Alright, end.
You have a 45-minute stream